All right, to get started with for advanced algebra, unit 1, we're going to be looking at functions. For today's first set of notes, we're going to look at how to find the domain and range of a function, as well as how to evaluate them. In order to do this, we have to have a clear understanding of what a relation is. A relation is a set of ordered pairs. So when you think of ordered pairs, think of you have an x coordinate, a y coordinate. Now these ordered pairs, or the relation, can be represented multiple ways. We could represent it in the form of a table, a graph, or even a mapping diagram. All three of these forms are represented down below. Keep in mind, when you think of domain, that is going to correspond to all your possible x values. Those are your input values that you're plugging into a function. Now, the range is all your possible y values. Those are the values that you get out of the function, or they can be known as your output values. So when they're asking you to find the domain and range, given a table, you can see in that picture in the top left, we have two rows, x row and a y row. Your x values, again, correspond to your domain. Your y values correspond to your range. So my input values are 3, 4, 5, 6. My output values are 1, 2, 2, 3. So when I go to list out my domain, I'm going to use curly braces and list out those input values of 3, 4, 5, 6. And for my range, I'm going to simply use 1, 2, and 3. Now notice here that the 2 was represented twice. We are not going to list any values that repeat inside domain and range. In the diagram below, we have a mapping diagram, which is representing the left side is all your input values, and then the arrows across are telling us what we get out of that function, which is going to be our output values or our range. So left side is domain, right side is our range. So when we go to list out our input values, again, we have 7, 5, 2, and 0, and those are corresponding to getting out 3, 6, 7, 10, respectively. And if you turn your attention to the right side here, you can see that we have a graph. So you can see that our x-axis is going to represent all of the possible x values, and the y-axis is all our possible y values. So looking at this given part of our graph, use a color here to highlight this. This is what's given to us as part of our function. Our domain is our x values, which start at 2, goes to 3, 4, 5, 6, and stops at 7. So we have our domain, our input values from 2 to 7. If I list those all out, it would be 2, 3, 4, 5, 6, 7. But rather than list out all of those input values, we can set it up as using set notation, which is going to say we're going to plug in all values that are bigger than or equal to 2, as well as less than or equal to 7. And then for our range is all our possible y values, and it starts with a y value of 3, goes and hits 4, and the highest point that it hits has a y value of 5. So our range is 3, 4, 5. Again, in set notation, that would be represented by using y is greater than or equal to 3 and less than or equal to 5. So that is set notation. Again, if you see set notation being requested in the directions, just know that's where you're going to be using your inequalities. There is another type of notation called interval notation. We'll be talking about that in the upcoming days. All right, moving forward, like I mentioned, Unit 1 is all about functions. So let's go ahead and tell you guys what the formal definition of a function is, and then we'll go through some examples. So a function is a relation. All right, we talked about what a relation is. So it's a set of ordered pairs in which each element of the domain, so each value of your domain, is going to be paired with exactly one element of the range. So for every input, I have exactly one corresponding output. So you can see right down here below, I have another one of those mapping diagrams. The left column is my domain, the right column is my range, and you can see that every single input value as part of my domain is going to correspond to exactly one output value of my range. So you can see here we have -3 corresponds to 5, 0 corresponds to 3, 2 gives me out 2, 4 gives me out -1. All right, that is a function. Each input has exactly one output. Now, from a graphical standpoint, we can use what's called the vertical line test to do a quick check to see whether or not a relation or a set of ordered pairs is a function or not. The vertical line test simply says if each vertical line passes through no more than one point of the graph of a relation, then that relation is a function. So what does that mean? So if I was to take my graph that's given to me and I draw a vertical line through it, no matter where I draw that vertical line, as long as it only hits the graph and intersects it only one time, then it is considered a function. So if I draw a vertical line through this graph or some given graph and it hits and intersects more than once, not a function. All right, so let's do some practice here. It says, state the domain and range of the following relation. We have 0, 2, -1, 5, -4, -7, 9, -8. Write your answer in set notation. So let's start off by just representing our x values, which is going to be our domain. So we have 0, -1, -4, 9. And for our range, that's our y values. We have 2, 5, -7, -8. Number 2, state the domain and range for the set of table values. Again, write your answer in set notation. So our domain, x values. So we have -4, -2, 0, 3, 6, 7, 8. Our range is our output values. We have 9, 4, -5, 5, -4, 7, -10. Right? Moving forward, number 3, state the domain and range of each graph. So looking at this first graph, we have our first x value starting at -4, and every single x value gets hit until I get to 5. So we could list that all out, -4, -3, -2, all the way to 5. Or to save us some time, we can go ahead and use that set notation, which would be x has to be greater than or equal to -4 and less than or equal to 5. And then for our range is all our possible y values. And when we write our range, we always go bottom to top. Probably noticed by now when I'm going through my domain, I go left to right. All right, so that's pretty standard. So again, domain left to right, negative to positive, range bottom to top, again, negative to positive. So starting from the bottom and working our way up, our first y value is at -3, hits at -2, -1, 0, 1, 2, 3, 4, 5, and then the highest y value is at 6. So we have our range going from -3 to 6. So our y values are going to be bigger than or equal to -3, less than or equal to 6. All right. Now, one big thing you need to take into account, and this is where we jump into the second example, you need to start looking at whether those points are included or not. So you can see here, this has an open circle or an open point. That tells us that that point does not exist for that given value. So at x is 1, it looks like I get out y is 1, but it's not actually included. So you need to make note of that, whether or not it's included. Whereas this point is filled in, that means it is included. All right, so included, filled in, not included is going to be an open or hollow circle. My domain, again, we'll go left to right. It starts at 1 and goes to 1's hit, 2's hit, 3, 4, 5, 6. So from 1 to 6. So 1 is not included for x. So we're going to have it be x is greater than 1. Again, we're not putting the equal to. And it is going to be going to less than or equal to 6. And then for our y values, we start at -5, -4, -3, -2, -1 is hit. zeros hit, and it stops at 1. So we're going to say that it's going to be greater than or equal to -5, because that y value was included here, and it's going to be less than 1. Again, 1 was not included, so it's not equal to. All right, and then for our last one, domain, let's go left to right. Now this arrow is telling us it goes on forever. So every single x value to the left of 1 is hit. So how are we going to denote that? We're going to just say x is less than or equal to 1. And x is greater than or equal to 2. 2's hit, 3's hit, 4's hit, and it goes on forever again. So we got x is less than or equal to 1, and x is greater than or equal to 2. All right, you might be a little confused with the fact that you might be saying, hey, wait a second. At x is 1, it's open, but it's also filled in. Well, there is a defined value at x is 1. We get an output value of 1, so it does exist. Same goes for at 2. This one's open, but this one was filled in. So at 2, there is a value that exists. It's at 3. So when I plug 2 in, I get out 3. For our range, our range is our y values. We start bottom to top. First value is 0, and it goes 0 to infinity. So every single y value, there's another color here, every single y value gets hit. It hits at 1, it hits at 2, hits at 3, hits at 4, 5, and so forth. So we're going to just say that y has to be greater than or equal to 0. All right, for the last part of our notes, we're going to look at how to evaluate a function. And in order to do that, we need to understand function notation. So let's consider this example. We have an equation y equals 3x minus 8. To write that equation in function notation, we're going to replace y with f of x. So y and f of x are essentially the same thing, just the notation's a little bit different. F of x is just simply saying I'm going to take some x value from our input value, we're going to plug it into our function, and you're going to tell me what we get out. So right below here it says in a function, x represents the elements of the domain, f of x represents the elements of the range. So going back to x is input, y is output, x is your domain, y is your range, x is your input, f of x is your output. Suppose you want to find the value in the range that corresponds to the element 5 in the domain. This would simply be written as f of 5. All right, so our input value is 5, so I'm going to plug 5 into that function, and f of 5 is how I would write that. So f of 5 is equal to, our function is 3x minus 8, but I want to know what I get out when I plug in 5. So I'm going to replace x with 5, and we get 15 minus 8 is 7. So f of 5 is equal to 7. Looking at some more practice, number 4, it says use the graph to evaluate each of the following. It says find f of 5 again. So looking at our graph, when I plug 5 in, what's my output, my range, my y value? So when I plug 5 in for x, I get a y value of 0. So my output is 0. At f of -2, here's -2. When I plug -2 in, we get an output value of -2. Since that's our y value again. F of 3, so when I plug 3 in, we get out 4. Again, just kind of going back to this relation. You have an x value, you have a y value. Letter D, now we're asked to find x, so we're finding the input value for when the output value f of x is 0. So what values of x do I plug in that will give me an output value of 0? So where do we get 0? We get it at 5 again and at -1. Both of those values, when I plug it into my function, I get out an output value of 0. So we're going to put x is -1 and x is 5. So -1 comma 5. Letter E, what values of x give us a output value of -5. So find x so that f of x is -5. Well, looking at this particular graph, when do we have an output of -5? Well, -5 is down here, right? We got -3, -4, -5. Right? There are no points that correspond to -5 as an output value. So we're going to write this as undefined. Since there is no input value, that gives me an output at -5. What's my domain? All right, so again, domain is all our x values. Remember, we go left to right. So it starts at -2, -1, 0, 1, 2, 3 is hit, 4, 5, 6, and then it goes on forever for all my x values. So to denote that, we're going to put x is going to be greater than or equal to -2 and less than or equal to 3, since 3 was included. And then there's a gap from 3 to 4 where no x values exist. So we're going to say then it goes from where x is greater than or equal to 4, since it's 4, 5, 6, and it keeps getting up bigger and bigger and bigger for all possible x values. And then for my range, let's take a look at this. Again, my range is all my possible y values. We go bottom to top, so -2, -1, 0, 1 is hit, 2 is hit, 3 is hit, 4 is hit, 5, 6, 7, and it keeps going on forever. So all values of y that are bigger than or equal to -2 are included in our range. Moving forward, number 5, it says use the table to evaluate the function. Pretty simple, f of 2. So that's saying when I plug in 2 into my input, what do I get out for my output? So when I plug in 2, I get out -1. When I plug in -6, I get out 10. And letter C, now we're asked to find what input value of x gives me an output value of 3. So when do we have an output value of 3? Right here. Output value of 3 is when x is 5. So 5 had to be my input. And at the very bottom, number 6, it says evaluate each of the following functions. We have f of x and h of x. So two different functions. F of x is equivalent to 3x minus 7. H of x is x squared minus x plus 3. So for letter A, it says find f of 2. So they're asking us to plug 2 in to the function f. So my function f is 3x minus 7. I'm going to replace x with 2. So 3 times 2 is 6, minus 7 is -1. Letter B says find h of -4. So now we're going to plug -4 in for x into the function h. So we have -4 squared minus -4 plus 3. Now notice, each time I plugged in a value for x, I used parentheses. I would strongly encourage you to do that because some of you guys, if you rely too much on your calculator and you don't type in the parentheses on your calculator, you're probably going to get the wrong answer. So watch this. -4 squared is really -4 times -4. That's 16. Minus the -4 is really +4 plus 3. So we got 20 plus 3 is 23. Letter C, we're going to plug in, this time we have a variable that we're plugging in, 4a plus 1 into our function f. So my function of f is 3x minus 7 again. So I'm going to plug 3, I'm going to put parentheses around x, and I'm plugging in 4a plus 1 and subtract 7. So we got to distribute. 3 times 4a is 12a plus 3 minus 7. Combine like terms, we get 12a minus 4. And for our last one, we got h of a plus 3, so they're asking us to plug a plus 3 in for x. So we have a plus 3 squared minus a plus 3 plus 3. A plus 3 squared, you have to write that twice in FOIL. Remember what squaring means. Multiply it by itself. So if I FOIL this, I get 8 squared, a squared plus 6a plus 9 minus a minus 3 plus 3. The -3 and 3 cancel. We got a squared plus 5a plus 9 as my output. So that is our lesson on an introduction to functions. We talked about domain and range, this concept of a relation. We know how to find the domain and range from both a table, a mapping, a diagram. We also talked about how from a graphical standpoint, we can tell whether or not a graph is a function by using the vertical line test.